Hello, Roman, and welcome back to the series of the videos Neural Networks from Scratch in Golang, where we're using a book called Neural Networks from Scratch in Python, but we're writing everything with the Golang. And currently I'm at the chapter 24, saving and loading models and their parameters. And by the way, I have a Discord channel you can join. We can talk about tech and stuff and coding. There is a main channel that I started before. There is not much new videos currently. I have some personal things I'm dealing with right now, so I should be, I will get back on the track on the recording of the more and more videos on the main channel too, in addition to this one, I think in August. But there are already around 40 videos that you can watch. So I would appreciate if you check it and you'll find something that will be interesting for you. Yeah, but let's go. And currently this week is a little bit weird for me, and there are a lot of things going on I have to deal with, so I'm a little bit slow on the neural networks from scratch today. And there is actually I'm kind of facing the new area of the serialization and the deserialization in the Go, and in the Go it's a little bit different with what I used to do, for example, in other languages. Well, it's not that different, but there are some deviations from the previous experience. So what I want to, the chapter 21 basically describes how you can implement retrieving of the parameters, saving, loading parameters, saving the model and loading the model. And for the for the Python, there is I think they use Pickle. And since the Python is a very dynamically typed language, you can do things like this, and you can, understand even the, variable name or variable class, etc. And this is why the pickle dump is very easy. So it can dump like the whole object with the class names, etc., which is not working in the Go. And my main issue, let me start it. My main issue currently is how to save the whole model. And if you take a look, there are, I mentioned in the previous video, and by the way, this video will be probably very short, as again, I have to deal with some other things. But there is an input layer, right? And this is the interface, right? There is, for the input layer, it's actually not a big deal because it's created here in the finalize method, and then it has its own forward method that just takes the data and stores it for the later usage. So this one is pretty easy too. But then with the output layer activation, that's basically the same. When I will call the finalize method, it will check if the last layer is actually an activation interface, because the layers is the layer interface. And if we talk, and the activation interface is actually a layer interface plus the prediction. So this is why we can store the activation interface inside the layers interface, because layer interface in that case is a subset of the function that has in this one. So it means that, and again, it will be instantiated properly with the finalize. So what I actually need to do, I need to serialize the input. Oh, not this one. I need to serialize the layers, all of the layers. There is a problem with this, not I think this one, but yeah. And you can see how many, why the implementation, this one is a little bit weird. Okay. There are several implementations of this interface, and I need to be able to serialize and deserialize all of them, which is the first problem for me. The second one is I have the loss, I have the optimizer, and I have the accuracy, and all of them are the interfaces. Yeah, so there is a loss interface, there is an optimizer, and there is the accuracy. And there are a bunch of the implementations that I have. So for example, for the accuracy, I have how many? Type binary, I have 3. For example, for the optimizer, oh, interesting. Actually, others not implementing the interface properly because I didn't use them since I introduced the interface. I need to fix it, but okay. And for example, for the loss interface, I have 4 losses, right? And why it's an issue? And actually, if save, yeah, so this one, you can see that I have a question how to marshal custom sequence, for example, how would marshal. And actually, I tried to experiment in a fresh setup to see what I can do. Well, actually, the first problem, even for the layer, because I use the dense class from the GoNum, you can see at the bottom, this is the GoNum version 0.15 dense. And you can see that there is no attributes for JSON marshalling, for example, or another marshalling, right? Which means that if I will do something like this, you know, like inputs, okay, inputs, it's not the best example because it's a private. Okay, so for example, if I will do, okay, this one, and I will do this, it won't be exported because the dense struct has no attributes marked. So there is no way I can export the layer as it is, right? That's the first problem. Second problem, it's actually represented here. I tried to replicate the structure that I have kind of to show what is the problem. And for example, right now I will do this because you will see why it's important. So I have the model, right? I have some layers and I have something called accuracy. Layers is the slice of the layer interface that has 2 implementations, right? So the same for the accuracy, that's some interface with some function, and it has 2 implementations, right? Seem for now more or less reasonable. And you can see that, for example, for the layers interface, I have 2 implementations, the layer 1, the layer and the layer 2 structs, and they have different internal values, by the way. Should be like this, right? That's it. For the accuracy, again, yeah, for the accuracy, I have just a function. And for example, if I will take a look at the activation functions here, for example, for the relu, well, okay, they actually have some things under the hood, but let's take a look. For example, okay, the drop layer has, okay, let's take a look at the loss. Okay, they actually have some data. Some of them are from kind of not inherited, that contains the base loss. Or for example, I have the optimizer that has its own things. Why it's all important? Here, for example, I have the calculate methods, but most importantly, okay, let's take a look. For example, I have the model. For the accuracy, I create a second accuracy, which has the function calculate that returns 10. Doesn't matter what the number is right now. Then I'm allocating two interfaces, and well, I'm allocating a slice for the layers interface from the two. Basically, for example, when I'm creating a model, I'm just adding, I'm adding the layer, then the activation function, then I can add, for example, a dropout layer, then again layer, some activation function, and so on. So we have the array of the interfaces, and I assign some values. You can think about this one as a layer, and this is the activation function, right? And I can, using marshalling, I can, so let's take a look. Go run main. You can see we have the layers. We have first layer with the value 1 value of this one, second layer with the value 2 with some text, and we have an empty accuracy. And even at that point, you can guess what will be the problem. And the problem is, sorry, will uncomment. I cannot unmarshal object into construct field model.layers of the type main.layer interface. Cannot unmarshal. Why is that? Because from this JSON structure, it doesn't understand what actual type it should allocate from this description. Same for the accuracy, it just didn't get to the parsing of the accuracy, but it will be the same. And I think, can I do this? Model? Yeah, so I cannot attribute types. So what it means? It means that in order to, if for example, my model was written in a different way, for example, I will have an array of the trainable layers. I have then array of the activations function. So of the concrete types, I won't use what's called the interfaces, then it would probably serialize it correctly. But since I'm using the interfaces, it doesn't understand what it means. It means that even if I will attribute it correctly, like here and here and here, and like JSON, whatever, I can attribute like this, but actually, I won't be able to do this because it won't be able to deserialize it, but I can, which means that I will have to do changes to the marshalling. Well, first of all, I will have to write the whole marshalling manually with the type checks, etc. For example, right, I will go through the layer and I will have to check for all of these possible types. For example, if it's a linear activation, well, maybe for the marshalling, I can create a method for the interface that will return the name of the struct. I don't know if it's possible to, using the reflection to do this. But then once I will do the unmarshalling back from the JSON, I will need to have the type concrete name, so I can then match the string and the type and allocate all the things manually. And that will require me to do some things. It will be a very manual process. It's like very different from what I possibly could have here. This one. But yeah, this is the goal, and I knew that when I started, this is like kind of it's not a downside, it's just a way. This is the plus of the dynamically typed languages, that you can do all of the things in the runtime, but it's upside. Well, this is kind of the good thing if you need to do something quicker, but usually it comes with the slower performance, etc., etc., and I actually don't like too much of this magic. Also, I will need to write a very custom saver. What I want to check today, this is the very, can I get the type name? For example, I have to go. Yeah, so there is a reflect type of this. Okay, let's try again. So for example, I have here, I will comment this for now. For example, fnt print reflect type of, for example, model. Then not this one. Model, then layers 0. One. And type of accuracy. Can I do this? Okay. Oh, interesting that it's kind of main dot. Okay, but basically what it means that I can store. I'm curious if I can create an interface that I will add into the other interfaces that can give me this. For example, type struct, type info, right? And then I have one t of the type info, type name, return string, and it returns reflect type of t. Why? Reflect type. Can I string, right? And can I do, for example, the accuracy type interface? Can't use type accuracy outside the type constraint. Interface contains, but I cannot do this neither. Pointer to, can I do this? No, I cannot. But I think I can do this, right? T type info, right? For example, I have here, I'm just thinking how I can make it easier for me. So then can I do this, for example, print ln type name from m.layers 0. Can I do this? The pointer to the interface, not the interface. This. Wait. Okay, so it. Okay, so basically I need to. Can I do this? Yeah, but in this case I don't have to. edit here, right? No, it's still the layer interface. But if I will do print ln will reflect type of m layers 0, it tells me that it's a layer. Okay. Like this. Oh, okay. So what's the conclusion? And I will stop for today. Yeah, I told you it will be a very short video. What's the conclusion? The conclusion that, well, actually, I need to understand if I can implement the marshalling and like marshalling, unmarshalling, for example, for the layer. But the way I will store it in the JSON will be different. So I won't be able to use the JSON annotations like this, but I will just, for example, if we take a look at the layer, what I need to store? I need to store a dense somehow. Dense is basically array of the values and the dimensions, and then I can load the one-dimensional array from the JSON and cap rows, cap calls, and then call the new dense and actually create the new dense for this. And I will need to do this for inputs, weights, outputs, and for the regularizar. The question is if, for example, I can do the annotation for this and then kind of take all of the pieces of the JSON and then somehow combine it into one big object. So this is, I'm still not sure how to do this in Go. I assume it's possible, or there is a just ugly way of doing and just create a dictionary and store all the things in dictionary and then just marshal it into the JSON data and read it into the disk. And then once again, because I can load JSON data into empty interface and then typecast it into the string, into the map of strings and empty interface again, and then do all of this type checks. But still I need to, for example, write a type name, etc. So I think that will be a lot of the code. I'm still kind of researching it, so hopefully next week I will actually finally implement it, because there is a very interesting part of the prediction and interface. This, all of the things we've done before was for this chapter, when we actually can make something useful for somebody and use our trained model to do the good things. And yeah, then create a server from it, and etc, etc. But for now, again, I need to go. I'm still trying to be consistent, and even spend 15 minutes on the learning is better than 0. The main thing is to be consistent in the learning process. That's the key. Thank you for watching, and I see you tomorrow. Bye bye.